Hey, what's going on, guys? Xiangqi here. Last video we ended up printing the Go band to the console, and I've been promising to add a support for variable board sizes. So we're going to be considering 9x9, 13x13, and 19x19 boards, which are the classical sets. It won't be supporting a custom board size just for now. Some engines do, but for now we can drop this. For it seems a bit of an overkill at this stage, in particular. So let's now do the following thing. So as far as this is a quick catch-up video, I could have done this like without covering, but actually want to emphasize this instead. So first, the changes that I've made. So currently we have the notation being supported for 19 by 19 board, and in order to stop properly where the specific board size is, I'm using the index slice in here, and also when we print in the rows, instead of having a fixed value here, we have the board range -1. So currently, if you want to change, let's just print the output. So here we have the 9x9 board. So here we have 13x13 board. So I need to change the where the board pointer is pointing to, what point the board pointer is pointing to. So pointing to board 13x13 in this case, right? So board width is equal to 13, and then we got this, the bigger board, and the same thing goes if we go 19x19. However, doing it this way is not the best ever thing, and if we want our program in future, if we wanted to dynamically switch the board sizes, like without escaping from the engine, without changing the code basically, but directly, but just calling a function. So for instance, the function like set board size, that would be doing two things: initializing the board, actually doing one thing, initializing the board of given size. In this case, it might make sense to actually implement that. So here, instead of this pre-coded values, we just have this. Let's make it equal to 0, for instance, for now. Margin would always be 2. This is okay. And board range is equal to 0 because we're going to be initializing this dynamically all of the time. So yeah, we can, since it's not calculated here, we just can put it here for now. So let's define here file markers. All right, so now let's create a function to set board size, set go ban size. Okay, and just want to define set board size, and size as an argument, and here we go. So if size is equal to 9, then we want to say the board width. Yeah, by the way, I've changed the variable name board size to board width because it's more like what it is. We might need the board size variable later on for some different options. So board width is equal to size, right? Well, actually, hold on a sec. In this case, we could just say, like, we don't even need this big switch case statement. We just can say, so board size is equal to size. Board width is equal to size, or better to call it width, right? Or yeah, maybe just call it size is okay here. Then board range is equal to board width plus margin. And yeah, actually, yeah, we still need, since we don't have, well, I could have made an array, a lookup array for this. Maybe I should do one. Yeah, probably let's do another. Let's say boards lookup. Just for initializing purposes, it should be just fine. So let's call it boards. Make it a constant like then. So for instance 9 would be pointing to board 9 by 9, right? 13 is going to be pointing to board 13 by 13, and this one pointing to board 19 by 19. I could make just a like sort of a switch case statement, or if, elif, but probably this should be working out. Since these are the pointers, should be fairly enough. So board array is equal to boards indexed by, and since this size is the integer, want to stringify it, so stringify the size, and that should be fairly enough. So now if we just run, now should give an error, or yeah, do nothing because we don't have a board yet. Where is the board? Oh, no, it's not because of the board, but because, yeah, by default board is equal to, let's make it equal to none. All right, and now if I say set board size, set board size and 9, for instance, should bring the, okay. Well, let's, in this case, it's not printing the board, but let's print. Okay, so I need to make this variables global, so obviously, so global board width and board range, since we're changing them. Yeah, margin is not needed. Yeah, it's not changing the margin, so it should probably not be the case. And well, board's probably also not gonna be there. So let's make sure that the variables got updated. So board width, we still have 0 for some reason. Okay, width typo. Okay, and yeah, and the board itself still none. Well, I'm not sure why. So the board seems to be 9 by 9 board. Okay. Okay. Then what's wrong with the board range? Maybe should be 11, which it is. Margin, which is 2. Well, this is a bit strange. So if I just try to print the board here, non-type. So board for some reason is a non-type. Oh, that's because, yeah, I also need to include the board here as well. All right, and yeah, now we got it. Okay, so 13 and 19. Well, this is great. So now we have 3 versions of our board to work with, which is great. Okay, so I think this is pretty much all about it. So yeah, so here, and also, yeah, probably, yeah, I just want to check out everything. So, well, for those who don't like using global variables, how would I say? Since we're not going for multi-threading in this project, then global variables are just fine. And also, the logic in this pseudocode does rely on the global variables because the 652 processor and with this unprotected memory, like it is for 6502, there is no other way to do like other than using those global variables. So that's just, and I just love global variables, and if there is no downside of using that, I prefer that, because that's really simple, straightforward, and as far as this tutorial is aimed for beginners, this is the case. But if you want to make this like an object-oriented way, you can just grab this entire code and wrap this into a class. And in this case, you don't need this global stuff. You just be referencing the class, the internal class variables. But I don't want to do that, because I don't want to go for those complications distracting from Go programming to Python programming, and I just don't want like the beginners to be distracted by this techniques used in Python. So for those who is not aware like how the object-oriented approach works, this might be like distracting factor. Okay, so probably one last thing. So I just want to define the main routine here. So def main, and we're going to be doing this within the main, and run the main. So main loop, main routine, and yeah, 19, 13, and yeah, for now we're going to be sticking to board size 9, so this should be fairly enough. Okay guys, this is it from my side. Thanks for watching, and in the next video we'll implement the most essential routine to actually calculate, to count to figure out whether the group of stone has been captured or not, and also count in the liberties for that group of stone. So that routine is called count, and gonna be covered within the next video in this series. Thanks for watching, until the next time, and take care.